Good morning, everybody. We are going to be starting a new unit on energy. This one's going to be a fairly short unit compared to our last one. And what we're going to start off with are different types of energy. So energy is the ability to do work or cause change. It doesn't mean that it's happening, that there isn't work being done or change happening. It is just the ability to cause change. And you know this in for example, a pencil or a book that's up high on the shelf. It has that ability, excuse me, to fall. It isn't necessarily falling, but if you were to take the shelf underneath it, it would. It would cause change. The majority of energy on our Earth originates from the sun. All the energy that moves through living things starts with the sun. Then we have photosynthesis occurring, and those plants are eaten by animals, and it moves on up through the food chain. But that's not the only form of energy. There's lots of different forms of energy that we're going to talk about today. And there is a strategy called Mr. Sense strategy to help you remember the different types of energy. So M is going to stand for mechanical energy. That's energy of motion. R, radiant. That's heat or light energy. C, chemical energy. That's energy that's stored in the bonds of chemicals. And when there's a chemical reaction, they can give off or use up energy. Electrical, that is the electrons traveling through our wires to get to our house to make our appliances work. Nuclear power is power that are right inside. Instead of a bond between atoms, they're inside just one atom. Thermal energy is energy of heat. And sound energy is, of course, energy that travels that we can hear. So first we're going to look at mechanical energy. It's the energy that we have in moving objects. It is the energy of motion or its energy of position. So a car that's moving has energy, or that book on the shelf also has energy. It can be either potential energy or kinetic energy, or a combination of both. So when you are in a swing, at the very highest peak of your swing, you have all potential energy. Then your swing kind of comes down through the curve. And as you're moving, that's kinetic energy. At the very bottom of your swing, you have no potential energy left. You're not going to go down any higher. And as you move up again, you have a combination of potential and kinetic energy. So some examples are spinning gears, a windmill, riding a bicycle. Radiant energy is energy of light. It's also on the electromagnetic spectrum, so we call it electromagnetic energy. It travels in waves, and it travels in a straight path from one place to another. So that energy, that light energy from the sun, takes about 8 minutes to reach us. It comes directly from the sun to us. Some examples are a TV, traffic lights, and a cell phone. Chemical energy are that energy that is stored in the bonds between molecules. And it's involved when chemical reactions take place. We've learned about endothermic and exothermic reactions. Some use up heat and others give off heat. That is some chemical energy. It is a form of potential energy. So, for example, when we eat our food, the bonds between those molecules in there are a source of potential energy for us. When we fill up our car with gasoline, there's potential energy in the chemical reaction that happens in our engine that will then give energy to the car. It is potential. So examples are food, coal, and a battery. Just sitting there by themselves, they are not making energy. But when we do something to the bonds in between those molecules that are inside the food or the coal, then we can get energy out of it. Electrical energy is energy what their electrons are moving or if there are electrical charges. We use it all the time in our daily lives, cell phones, TVs, hair dryers, our stove, our refrigerator. It was first used in the late 1800s in homes. Before that, they did not have the kinds of things that we do to light their homes. They used candles or lanterns. So we've got a lamp, electrical outlets, and chargers as examples of electrical energy. Then we have nuclear energy. This is the energy that's not locked inside the nucleus of an atom, just one atom. And nuclear fission is the process of splitting it apart, taking apart those subatomic particles and breaking the bonds that hold them in the nucleus of the atom. Nuclear fusion is where two or more atoms join together to make a larger atom, and it has to be under a lot of heat and pressure, and atoms have to be moving really fast in order to have a joining together. And that takes place in the sun. The sun is made mostly of hydrogen atoms, and as they are moving around in the sun, they will bond together to form larger elements like helium or oxygen. Takes place in all stars. Examples of nuclear energy are the sun or stars, power plant like we have near Mooresville, the Duke power plant out that way, and of course in the atomic bomb that was used in World War II. Thermal energy is energy of heat. Particles of hot objects move faster than particles of cooler objects, and that kind of should make sense to you if you start thinking about states of matter. The molecules in a cube of ice are not moving very much at all. When we heat it up and they become liquid, well, they can move a little farther apart. And if we keep adding heat to it, eventually the molecules are going to move so fast that they're going to start evaporating into the air. So the more thermal energy something has, the hotter it is, and the less thermal energy, the colder it is. So an iron has thermal energy, a toaster, and a fire are all forms of thermal energy. Sound energy, the energy from vibrations in matter. We know that sound can travel through solids, liquids, and gases, but it has to have something to travel through. So sound does not travel in space. There is no solid, liquid, or gas in space for it to travel through, so there's no sound there. We can use a bullhorn, our alarm clock that wakes us up in the morning, or a radio are all examples of sound energy. So some questions for you to think about. What form of energy is produced by a musical instrument? Identify and describe 3 different forms of energy found within your room. Is it possible for an object to use or contain more than one form of energy? Explain. What forms of energy are used by a light bulb? And last, for you to think about, which form of energy do you believe is most important for survival and why? So those are our sort of brief introduction or reintroduction to types of energy that you should have had before. You are going to do, those of you who are C students, you're going to go ahead and you are going to work in your interactive notebook, and there are definition and pictures of examples of all of those. Group B students, you're going to do this in class on Thursday. We will put those together. If you have any questions, please let me know, Zoom with me or email. See you later, guys.